All right, in statistics today, we're looking at probability, basic principles of probability, and this is part 1. Okay, in probability, we have this right here. This is the probability of an event. We're going to talk about events here in a minute, but probability of an event is the number of desired outcomes divided by the number of total outcomes. All right, so we can look at that as in this quarter right here. If I'm going to flip this quarter, okay, and I call heads, the number of desired outcomes on this coin, there's one head. So this would be 1. The total outcomes, well, we have a head and we have a tail, so there's 2 total outcomes. So this is my probability of flipping this coin and getting a head. Okay? We have outcomes and we have events. An outcome is the result of a single experiment. So like my outcomes here on this, a tail or a head, that's my outcomes. Okay, but now there's only one that's desired, one outcome that's desired. Okay, now event is a set of outcomes. Like I want to flip this coin and I want to get a head. That would be my event. That flipping the coin would be the event. Let's look at it like this right here, a cube. If I was rolling this die, I have these outcomes, 1, 2, 3, 4, or 5, or 6. There's 6 different outcomes I could have here. Okay. My event would be if I flip this, and so I'm desiring my probability of getting a 5. Okay, that's my event, that I roll this die and I get a 5. All right, what's desired? Well, there's only one desired out of that. There's only one 5. Now, how many total? There's 6 total. So this would be a 1/6 probability. Now, another thing we're going to be talking about in here is the sample space. Sample space is the set of all your possible events, or maybe this should be outcomes. The sample space is what you could possibly have. So when I'm rolling this die, my sample space could be 1, 2, 3, 4, 5, or 6. That could be my sample space. Now, there's one thing to know about probability. Okay, let me get this straightened up here. In probabilities, the probability of an event has to be greater than or equal to 0. It can be 0. Like for instance, if I shoot 10 free throws, okay, what's the probability that I make 11? Well, you can't. If you're shooting 10, there's no way to make 11. So the probability of that would be 0. It is possible to have 0 as a probability. Now, another thing is probability of an event has to be less than or equal to 1. Okay, so like if I shoot these 10 free throws, what's the probability that I make 1? Okay, well that won't be it's possible I could make 0, I could make none, but it is possible to have a probability where it's 100% going to happen. We could write it like this right here. The probability of event would be between 0 and 1. Okay, so probabilities have to be between 0 and 1. Now you could have a percent like 60%. Or 75%, because that's 75 out of 100, which is less than 1, and it's greater than 0. So probabilities have to be between 0 and 1. Okay, now another thing we have is a complement. Okay, a complement is we usually have an event and we have this little prime symbol. So this means it's complement, which is 1 minus the probability of that event happening. And what this means is, like, suppose that we have a 40% chance of rain. So that's an event that we're looking at a 40% chance. All right, what's the probability that it does not rain? That's the complement. So that's going to be 1 minus 40%, which would be 60%. This is the complement. This is if it does not rain. Okay. Then we have a probability of multiple events. So like suppose I'm going to flip this coin and I'm going to roll the die. And suppose when I flip this coin, I want the probability of getting a head. And when I roll the dice, I want the probability I want to get a 5. All right, so my probability here, there's only 1 head out of 2 total. To roll this die to get this 5, there's only 1 5 out of 6 total. So now what's the probability that I do both of those? I would multiply them, which would be 1 out of 12. And that'd be my probability that I do both. You could look at this coin here. Suppose I flip this coin 3 times. What's the probability that I get all 3 heads? Okay, so I'm going to do it 3 times. What's the probability to get all 3 heads? Let's see if I can do this. Okay, there's one. Oh, that's a tail. Okay. Oh, there's a head. And there's a head again. So I got a tail and 2 heads, but I didn't get all 3 heads, did I? So I didn't get what I was wanting. But what would be my probability of that? All right, so I break it down like this. There's 3 tosses. I want a head for each one of these tosses. So my probability here would be 1/2. My probability here would be 1/2. My probability here would be 1/2. So if I multiply those, that's going to be 1/8. So I've got a 1/8 probability. Okay. I could write out my sample space for that. Okay. Let's do it right here. I could get all 3 heads. Okay, I could get the first 2 heads, but then this one be a tail. All right, I could have a head here and a tail and then a head. Okay, or I could have a head and a tail and another tail. Okay. Then I could have this to be a tail, but these be heads. Tail, head, tail, 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 head, tail, tail, tail. I'm missing one. No, that's 8. 2, 4, 6, 8. There's all 8 of them right there. So this is my sample space right here. That's what I could end up with, my possibilities. Okay. Well, let's look at some problems that we're going to have. What's the difference between an outcome and an event? Choose the correct answer. Okay. The outcome is just one single probability experiment. An event is the set of your outcomes. So let's see what we have here. Which one? Right here. D. Outcome is the result of a single probability experiment. An event is a set of one or more possible outcomes. An outcome is just a single probability experiment. An event is a set of one or more possible outcomes. Now, let's go back to this. Let me explain what that is. Now, this is these are my possible outcomes. Each one of these, there's 8 possible outcomes. Now, this event was what I wanted all 3 heads, which is this one. Now I could have had this, probably that I had 2 or more heads. Okay, well, that one would work, that one would work, this one would work, this one would work, and that's it. So there's 4 of those. So this is an event which has 4 possible outcomes. So an event could have 1 or more, but an outcome is just a single result. All right, let's go to the number 2 here. Determine which numbers could not be used to represent the probability of an event. Okay, well, look at this one here. We cannot have a negative. It's got to be, remember now, the probability of an event has to be greater than or equal to 0, but it has to be less than or equal to 1. It's got to be between 0 and 1. This is negative, so that can't happen. Now right here, this is between 0 and 1, so that's okay. 33%, 33.3%, that's 33.3 over 100, which is between 0 and 1. Now this one here, there's a problem. 64 out of 25, that's more than 1. 0, okay, probability can be 0. And then right here, this is 320 over 1058. As long as this top number is less than the bottom number, that's good. So there's 2 here that cannot be a probability. All right. Number 3 here, explain why this statement is incorrect. The probability of rain tomorrow is 145%. What makes this statement incorrect? Well, you can't have more than 1. And see, this is 145%, which is 145 over 100. And see the top number, well, let's put X. The top number is bigger than the bottom number, and you can't do that. All right, so looks like B here is my answer. The probability is it cannot exceed 100% because it cannot be greater than 1. Okay, number 4. Choose the 3 formulas that can be used to describe complementary events. Select the 3 formulas. All right, now remember now, the probability of a complement is going to be 1 minus the probability of that event. Okay? Like we had a minute ago. We were talking about this. There's a 40% chance of rain. All right, what's the probability that it doesn't rain? Well, it's going to be 1 minus the 40%, which is 60. Okay. So let's look at this right here. There's 3 that are good. This one's not good here. This really should be a plus. The probability of an event happening plus the complement, that should equal 1. Like right here. That's what this one is. So there's one of them right there. I think we got the other 2 right here back to back. The probability of a complement equals 1 minus the probability of that event. And then the probability of the event is 1 minus the probability of the complement. See, I can add this to both sides, which makes this go away, just doing some algebra here. And so P of E prime plus P of E equals 1. So that gives me this one down here, see? And then I could subtract this on both sides. And that'll go away, and I have probability of the event is 1 minus probability of the complement of the event. All right, so there's my 3 formulas right there. All right, number 5. Determine whether it's true or false. Okay? You toss a coin and roll a die. The event tossing tails and rolling a 6 or 4 is a simple event. All right, simple has just one outcome. See, this will have a few outcomes because I can have 6 or 4 tossing tails and a 6, or tossing tails, and a 4. So this one is false. Okay, now let's look and see why it's false here. Right here. The event is not simple because it consists of 2 possible outcomes. A simple event just has 1 possible outcome. This is not simple because it has more than 1 possible outcome. Okay, number 6. Determine whether the statement is true or false. All right, you toss a fair coin 9 times and it lands tails up each time. So you've tossed it 9 times, you've gotten tails 9 straight times. The probability that it will land heads up on the 10th flip is greater than 0.5. Now, this is not true because each time you flip this coin, it's got a probability of 0.5 to be heads and 0.5 to be tails. So even though I've done this 9 straight times and I've gotten tails 9 straight times, I could flip it again and it could be tails again. So the statement is false. So it's one of these 4 here. It's not true at all. Okay, now we've got to read through here and see how it's rewritten correctly. Okay, so A, the correct statement is you toss a fair coin 9 times and it lands tails up each time. The probability it will land heads up on the 10th flip is 0. That's not right. You toss a fair coin 9 times and it lands tails up each time. The probability it will land heads up on the 10th time is exactly 0.5. This is it right here. B. This says here that it'd be less than. See the difference here? It'd be less than 0.5. No, it's going to be 0.5. And then B here. It tosses 9 times, it lands tails up each time. The probability it lands heads up on the 10th flip is 1. No, it's not going to be that. The answer is B. Because when I flip this, no matter how many times I flip it, it's going to be 0.5. Number 7. Determine whether the statement is true or false. Is it true or false? Okay. When an event is almost certain to happen, its complement will be an unusual event. Okay. Now I think this is true. So the answer would be A. That's the only one that says true. What this means is, suppose you have an event that's almost certain to happen. So like suppose you have an event, the probability of whatever this event is 0.975. Okay? That's the probability of this event happening. That means the probability of the complement of the event would be 1 minus that. And if I do 1 minus that, I get 0.025. So if this is almost certain to happen, this is going to be unusual. This is like 2.5%. This is not going to happen very much. So this is true. If you have one event that's almost certain to happen, then that means the complement is going to be unusual. It's not going to happen very often. Number 8. A random number generator is used to select an integer from 1 to 100 inclusively, which means it's going to be in between those numbers and include 1 or 100. So we have 100 different outcomes. 1, 2, 3, 4, all the way up to 100. Inclusively means it includes 1 and it includes 100. Okay? What's the probability of selecting the integer 769? Well, how are we going to do that? If we're selecting from 1 to 100, how are we going to get 769? It's not going to happen. So this is 0. This has a 0 probability. All right, number 9. You randomly select an integer from 0 to 4. Now, look here. Inclusively means it could include 0 and it includes 4. So look here. 0, 1, 2, 3, 4. Look, there's 5 possible outcomes there. All right, so you randomly select one of these integers and then randomly select an integer from 0 to 7. inclusively, which means it includes 0 and 7. So look here, 0, 1, 2, 3, 4, 5, 6, 7. Okay, which there's 8 of those. So we've got 5 outcomes here, we've got 8 outcomes there. Okay. Now it says in here, what's the probability of selecting a 2 both times? What's the probability you get a 2 both times? All right, so in this chance right here, to get a 2, there's only one 2, and there's 5 total. In this one, there's only one 2 again, but there's 8 total. So if the probability here is 1/5 and the probability there is 1/8, then the probability of doing both, I multiply these, which would be 1/40. Okay, now you got to pay attention to this right here. This says type an integer or a decimal. All right, so 1/40. All right, if I just do 1 divided by 40, okay, I get 0.025. Okay, number 10. 7 of the 200 digital video recorders in an inventory are known to be defective. What's the probability you randomly select a DVR that's not defective? All right, 7 out of 200 are defective. So that's my event there. Okay, what's the probability of the complement of that? What's the probability that they're not defective? So what I'm going to do is I'm going to do 1 minus this. Okay, so let's do that. 1 minus 7/200. Okay, I get this right here at 0.965. But you have to pay attention here because it says type a decimal. It says type a decimal or an integer. All right, so that's my answer there, 0.965. I thought it was going to ask for a fraction since it told us. Well, it didn't say fraction. I guess maybe I saw this fraction down here and I was thinking it had to be a fraction. But you got to pay attention what it wants your answer at. So this one here says fraction. So this one here we got to have it as a fraction. Let's do it. The probability that an event will happen is this right here. Find the probability that the event will not happen. All right, so that's my complement. I'm going to do 1 minus 18/23. All right, so let's do that one. 1 minus 18 divided by 23. Okay, now let's change that to a fraction. 5/23. Okay, and that'd be my answer. You got to make sure if you put that decimal answer in, it will not count it. So you got to make sure you do that. The probability that an event will happen is this right here. Find the probability that the event will not happen. All right, so we're going to do 1 minus 0.32, 0.68. Okay. But this right here, the probability that an event will not happen is 0.96. Find the probability that the event will happen. I got to do 1 minus 0.96, which is 0.04. Okay. Number 14 down here. The probability that an event will not happen is this. Find the probability that it will happen. I got to do 1 minus 19/20, which is 1/20. And look, it says type it as a fraction. Okay. All right. Number 15 here. Identify the sample space of the probability experiment and determine the number of outcomes in the sample space. All right, so we're randomly choosing a number from the even numbers between 1 and 10. All right, the sample space is, all right, 2, 4, 6, 8, and 10. It says inclusive, which means it includes 1 and 10. So that's my sample space. There are how many outcomes here? Well, it looks like 5. There's 5 outcomes. Number 16. Okay. On 16 here, identify the sample space of the probability experiment and determine the number of outcomes. All right, playing the game of roulette. Now, roulette, you've probably seen this on TV, where they spin the wheel and they throw the ball on there. The wheel consists of slots number 0, 0, 0, 1, 2, and all the way up to 36. To play a game, a metal ball is spun around the wheel and is allowed to fall into one of the number slots. Identify the sample space. The sample space, I think, would be this one right here. 0, 0, 0, 1, 2, all the way up to 36. C. Now, how many outcomes is that? Okay, well now, from 1 to 36, there's 36 there. Then we have 0, and we got 0, 0, so that'd be 38. Okay. All right, number 17. Okay, let me get this thing on here. Identify the sample space of the probability experiment and determine the number of outcomes in the sample space. Draw a tree diagram. Determining an athlete's sport, baseball, soccer, or football, there's 3 sports and the skill level, low, medium, or high. There's 3 of those. So there's 3 of these and there's 3 of those. Identify the sample space. Well, since there's 3 of these and 3 of those, 3 times 3 is 9. There should be 9 of them. Look for the one that has 9 because they're all different. It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. It has to be this one here, I think. These have more. Yeah, look at this. Look at this. SH and SH. See, they got that on there twice. SM and SM. See, that's on there twice. So this will be my sample space, which means baseball low, baseball medium, baseball high, soccer low, soccer medium, soccer high, football low, football medium, football high. There's the sample space. And there's 9 outcomes. Okay. Now I've drawn a tree diagram here to draw out our sample space. And looking at right here. It's got to be this one. Because see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 outcomes. This is BL, BM, BH, SL, SM, SH, and so on. Okay, getting close to finishing up. All right, determine the number of outcomes in the event. Decide whether the event is simple or not. A computer is used to select randomly a number between 1 and 9 inclusive, which means it could include 1 and 9. Event C is selecting a number greater than 8. All right, so of these numbers, 1 through 9, how many of them are greater than 8? Well, there's only one of those. 9. 9's only one, so there's one outcome to that. Okay? Now, is the event a simple event? Yes, because it just has one outcome. It has exactly one outcome. If you have one outcome, that's a simple event. Okay? What about 19 here? Determine the number of outcomes in the event. Decide whether the event is simpler or not. You randomly select one card from a standard deck of 52 playing cards. Event B is selecting a red card. Okay. Now, if you know anything about cards, you have 4 suits. You got diamonds, you got hearts, and you got the clubs, which looks something like this. And then you have spades, which looks kind of like this. There's your 4 different ones, okay? Well, as far as red, these 2 are red. And these 2 here are black. These 2 here are black. Okay? Now, these red ones, there's 13 diamonds and there's 13 of those. So if I add them up, there's 26. So this has 26 outcomes. Okay? Is that a simple event? No, because it has more than one outcome. It has more than one outcome. So it's not a simple event. Now, if you look at this, what about, what if I randomly select and I want the ace of spades? Okay. How many outcomes is that for that? Well, there's only one of those. Now, is that a simple event? Yes, that's a simple event because it has exactly one outcome. Okay. So that's all we're looking at today. Basic principles from probability, part 1. If you have any questions, give me a shout, okay? Have a good rest of the day.